Hi, my name is John Jarina, and I had question number 9 for Chapter 8, which stated to balance the following equations, which go through letter A through N. So first we had dinitrogen pentoxide, which yields dinitrogen tetroxide and O2. Whenever we balance the equation, we end up with 4 nitrogens on each side and 10 oxygens on each side to give us 2 moles of dinitrogen pentoxide, 2 moles of nitrogen tetroxide, and 1 mole of O2. Next, for letter B, we have potassium nitrate, which yields potassium nitrite and O2. So whenever we balance this out, we want to end up with 2 potassiums, 2 nitrogens, and 6 oxygens on each side, and also which gives us 2 moles of potassium nitrate, 2 moles of potassium nitrite, and 1 mole of oxygen, O2. For letter C, we have ammonium nitrate yielding nitrous oxide and water. So whenever we balance this equation out, we want 4 nitrogens on each side, 8 hydrogens on each side, and 6 oxygens on each side to give us 2 moles of ammonium nitrate, 2 moles of nitrous oxide, and 4 moles of water. For letter D, we have ammonium nitrite, which yields N2 and water. So whenever we balance this equation, we end up with 2 nitrogens on each side, 4 hydrogens, and 2 oxygens, and that leaves us with 1 mole of ammonium nitrate, 1 mole of N2, and 2 moles of water. For letter E, we have sodium bicarbonate yielding sodium carbonate, water, and carbon dioxide. So for letter E, we want to end up with 2 salts on each side, 2 sodiums on each side, 2 hydrogens on each side, 2 carbons on each side, and 6 oxygens on each side to give us 2 moles of sodium bicarbonate, 1 mole of sodium carbonate, 1 mole of water, and 1 mole of carbon dioxide. So let's flip this over and go on to letter F, which is, letter F is phosphorus pentoxide plus water yielding phosphoric acid. So for letter F, we see that we want to get 4 phosphorus on each side, 16 oxygens on each side, and 12 hydrogens on each side to give us 1 mole of phosphorus pentoxide plus 6 moles of water to yield 4 moles of phosphoric acid. For letter G, we have hydrogen chloride plus calcium carbonate yielding calcium chloride plus water plus carbon dioxide. So for letter G, we want to end up with 2 hydrogens on each side, 2 chlorines on each side, 1 calcium on each side, 3 oxygens on each side, and 1 carbon on each side to yield 2 moles of hydrogen chloride, 1 mole of calcium carbonate, yielding 1 mole of calcium chloride, 1 mole of water, and 1 mole of carbon dioxide. For letter H now, we have aluminum plus sulfuric acid yielding aluminum sulfate plus H2, which is hydrogen, which is 2 atoms of hydrogen. So for letter H, we want to balance this to get 2 aluminums on each side, 6 hydrogens on each side, 3 sulfurs on each side, and 12 oxygens on each side to get 2 moles of aluminum plus 3 moles of sulfuric acid, yielding 1 mole of aluminum sulfate and 3 moles of H2, which is hydrogen. Now for letter I, we have carbon dioxide plus potassium hydroxide yielding potassium carbonate and water. So for letter I, we want to get 1 carbon on each side, 4 oxygens on each side, 2 potassiums on each side, and 2 hydrogens on each side to get 1 mole of carbon dioxide, 2 moles of potassium hydroxide, 1 mole of potassium carbonate, plus 1 mole of water. Next, we move on to letter J. So for letter J, we have methane plus O2 yielding carbon dioxide and water. Whenever we balance this equation, we want to get 1 carbon on each side, 4 hydrogens on each side, and 4 oxygens on each side to yield 1 mole of methane plus 2 moles of O2 yielding 1 mole of carbon dioxide and 2 moles of water. For letter K, we have beryllium carbide plus water yielding beryllium hydroxide plus methane. So for letter K, what we do here now is want 2 berylliums on each side, 1 carbon on each side, 8 hydrogens on each side, and 4 oxygens on each side to give us 1 mole of beryllium carbonide plus 4 moles of water, yielding 2 moles of beryllium hydroxide and 1 mole of methane. So for letter L, we have copper plus nitric acid yielding copper 2 nitrate plus nitrogen oxide and water. So for letter L, we want to end up with 3 coppers on each side, 8 hydrogens on each side, 8 nitrogens on each side, and a whopping 24 oxygens on each side to give us 3 moles of copper plus 8 moles of nitric acid yielding 3 moles of copper 2 nitrate plus 2 moles of nitrogen oxide and 4 moles of water. Now next, for problem M, we see that we have sulfur plus nitric acid yielding sulfuric acid plus nitrogen dioxide and water. So for letter M, we want to end up with 1 sulfur on each side, 6 hydrogens on each side, 6 nitrogens on each side, and 18 oxygens on each side to give us 1 mole of sulfur plus 6 moles of hydrogen plus 6 moles of nitric acid, yielding 1 mole of sulfuric acid plus 6 moles of nitrogen dioxide and 2 moles of water. Now for our last problem, problem N, we see that we have ammonia plus copper oxide yielding copper, nitrogen, and water. So we want to end up with 2 nitrogens on each side, 6 hydrogens on each side, 3 copper on each side, and 3 oxygen on each side once we balance out the equation. And that will leave us with 2 moles of ammonia plus 3 moles of copper oxide yielding 3 moles of copper, 1 mole of nitrogen, and 3 moles of water. That is all for problem number 9, and I hope that this helped whoever watches this with solving the problem and getting the answer. Have a good night, and thank you for listening.